finding the absolute maximum and minimum of the function f of x equals to x to the fourth minus 4x to the third plus 4x squared minus 1 within the closed interval from 0 to 2. So the first step is, let's find the first derivative. So we have f prime of x that is equals to 4x to the third minus 12x squared plus ax, and then the derivative of 1 is equals to 0, and then we have to set this equals to 0 because this one helps me to find the critical point, and then we have to do a factor. So let's take a 4x out, so we have x squared minus 3x plus 2, and then let's factor this one more time. So this is a negative 3 positive 2, so that is x minus 1 and x minus 2 equals to 0. So therefore x equals to 0, x equals to 1, and x equals to 2. They are my critical numbers, right? So critical numbers. What is critical number? So critical number is you have a point, and then at this point there is a horizontal tangent line. So and then you can use the second derivative test or sign chart. So for a sign chart, let's say you have the slope up and down, then the critical point is a maximum. If the slope is down and then up, the critical point is a minimum. All right. And then let's see what else. The next step is, do we need any sign chart or second derivative? The answer is no. All you have to do is you test the endpoints of the interval and you test the critical numbers. All right, so let's do the test. So we draw a table. And then this is from 0 to 2. So 0 is also a critical number. So we will be testing 0, 1, and 2. And then f of x. So how do we test a 0? So all you have to do is you plug in 0 to the original function, not the first derivative. Because you are testing the location of a point, you have to plug it into the original function. So we have 0 to the fourth minus 4 0 to the third plus 4 times 0 square minus 1, so that is equals to negative 1, right? So when x is equals to 0, y is equals to negative 1. So when you test the other point, when x is equals to 1, y is equals to 0. When x is equals to 2, y is equals to negative 1. So to find the absolute mean and max, all you have to do is you have to find the highest y and the lowest y. So where is the highest y? The highest y is 0, right? So that means this is the absolute max, and then the coordinate is 1, 0, and then for the smallest y, so they will be the negative 1. So there are two absolute minimum. So one right here, so this is an absolute minimum at 0, negative 1, and then absolute minimum at 2, negative 1. So let's use the picture to verify our answer. We only need from 0 to 2. So from 0 to 2, so that will be right here, right? So from 0 and then all the way to 2. So that's it. So do we agree that at this point, we have this is as the absolute maximum and these two as the absolute minimum, the highest point and the lowest point. Right? And then let's do a what if. So what if I change the closed interval a little bit? So let me use a different color to do the change. So let's say I change the closed interval to, how about this, negative 1/2, 2. If I change the closed interval, then you have to change the testing. So from negative 1/2 to 2, I can still include those three critical numbers, but when you test the endpoint, you also need to test negative 1/2. So the testing is this. So we have x, and then you have to test the negative 1/2, 0, 1, and 2. So the 0, 1, and 2, no change. This is still a negative 1, 0, and negative 1, right? So when x is equals to negative 1/2, can you take a look at this screenshot right over here? So all you have to do is you plug in f of negative 1/2, right? So f of negative 1/2, so you plug it in, and then the answer is equals to 0.5625. But sometimes when you have a rational function, you might have to approximate your answer. The problem is when you are doing homework online, the online system may not accept approximation. The reason I bring this up is because in the screenshot, I teach you how to use your calculator to put the decimal or approximation back to a fraction. So all you have to do is you hit the math key. So look at the first screen, look at this screenshot. So all you have to do is you hit the math key on your graphing calculator, TI-83, TI-84 plus, and then you select the first option, the fraction, FRAC. So when you click the FRAC, you will see the answers goes to fraction. That means you are asking your calculator to put the decimal to a fraction for you. As a result, you have 9/16. But when you do the comparison, I agree with that. It is easier to use decimal. So when you do your scratch work, I agree, it is easier to use the decimal, right? Because you don't want to work with the denominator. But when you enter an answer to the online homework system, they might only accept fractions, no approximation. Okay, so back to our business. Which one is the highest? Which one is the lowest? I can copy the graph for you. So copy and then paste. I can paste that right over here so you can see it. So if you go from -1/2 to 2, it looks like this is no longer the absolute max, then this is the absolute max, right? So because that is the highest, so this is the absolute max. And then what about the absolute min? The two negative ones, right? So this is the absolute minimum, and this is the absolute minimum. So 2, -1, and then 0, -1. When you report this to an online homework system, they might want to see this when x is equals to 1/2, y is equals to 9/16, not the decimal. If the decimal is not an approximation, they will accept it. But if the decimal is an approximation, so let's say approximating one third, then you will have to use calculator, right? So this will save you a lot of time from doing common denominators. Okay, so let's do two more. Okay, let's do two more. The next one I would like to use is a closed interval from 1 to 3. So what are our critical numbers? Our critical numbers are 0, 1, and 2, right? So from 1 to 3, which critical numbers should be ignored? The answer is 0, right? Because 0 is outside the interval. So this is outside 1 to 3, right? So we can just ignore the 0. Forget it. I only need from 1 to 3, 0. I don't really care. And then you have x, and then you have your f of x. So this time we start at 1, and then count the 2, count the 3 as well. So when x is equals to 1, y is equals to 0, 2 gives you -1, and 3 gives you 8. So clearly 8 is the highest, right? So this is absolute maximum at 3, 8. So look at the picture, 3, 8. So x equals to 3, y goes all the way up, right? And then the lowest is -1. So this is absolute minimum at 2, -1. Last one. How about 3, 5? Which critical numbers should be ignored? Tell me. 3 to 5. Are they in the interval? The answer is no. So we are going to ignore all of them. So they are not in 3 to 5. Okay, so they are not in 3 to 5. So we will have to do x and then f of x. So we will be only testing the 3 and 5. So when x is equals to 3, y is equals to 8. So this is 224. So this is the absolute maximum. And this is the absolute minimum. The reason that we have to test the derivative is because when you use a higher degree polynomial, there are turning points like this, right? So the reason that we will have to test the f prime of x is because we want to find out these points as well. So other than the two endpoints, we will also want to find out the relative minimum and relative maximum, because a relative minimum can also be the absolute minimum, and also a relative maximum can also be the absolute maximum. So that's why we have to find the f prime of x and then set that equals to 0. So here is that's the reason of doing this. Okay, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video in any social media for me. If you are new to the channel, spend 2 seconds to click the subscribe button for me. Appreciate for your help. Thank you. I will see you all in the next one. Signing out.